8.2, graphing rational functions. A rational function has the form f of x is equal to p of x over q of x, where p of x and q of x are polynomials, and q of x cannot equal 0. The inverse variation function f of x is equal to a over x is a rational function. The graph of this function when a equals 1 is shown below. Let's take a look at our parent function. The graph of the parent function f of x is equal to 1 over x is a hyperbola, which consists of two symmetrical parts called branches. So take a look at the right. The domain is the set of all real numbers x such that x cannot equal 0. And the range is a set of all real numbers y such that y cannot equal 0. Any function of the form g of x is equal to a over x, where a does not equal 0, has the same asymptote, domain, range as the function f of x is equal to 1 over x. So let's take a look at our parent function. I'm going to take note of my points. I'm at 1, 1, and -1, -1. And I'm going to go ahead and highlight my vertical asymptote and my horizontal asymptote as well. And let's take a look at our function. So at the top, my function is approaching the green. At the bottom, my function is approaching the green. On the left, my function is approaching the blue. And on the right, it's approaching the blue as well. Let's take a look at Hoy-Vooks. So you learned this in Algebra 1. Horizontal, 0. That's your y equals. So for horizontal line, you're going to be writing y equals. For vertical lines, you'll be writing x equals. So notice that it matches up perfectly with our graph. Let's take a look at an example. So it says graph g of x is equal to 4 over x. Compare it to the graph of f of x equals 1 over x. So notice I already have f of x already graphed on here. It's the same graph as earlier. I told you to take note of points 1, 1 and -1, -1. And what I want to do now is I want to graph g of x in Desmos and find some points. So I'm going to go to Desmos. I already have it typed in. I'm going to go to my table to find some points, and I'm going to look at points 1, 2, and 3. And I'm going to write down those values onto my notes. So let's go back over here and copy those down. So I have 1, 4, 2, 2, 3, 1.3. Let's go ahead and plot them as well. 1, 4, 2, 2, 3, 1.3. And connect. And we're going to do the same thing with the negatives. So let's take a look at the negatives on Desmos and compare it to the positives. So we had +1, +4, and now we're at -1, -4. So both of the signs switched. Same thing. We had +2, +2. Now we have -2, -2. So we're going to make sure we mention that on our notes. We have -1, -4, -2, -2, and we have -3, -1.3. Let's go ahead and connect these. And I'm going to label this graph G. So G is the pink. All right, so now we want to compare. So let me switch colors. So notice that both of these graphs are in the first and third quadrants. So both graphs are in quadrant 1 and quadrant 3. And since it's of the form a over x, then that means it has the same asymptotes, domain, and range as a function f of x. So let's mention that as well. So it has the same D for domain, R for range, and A for asymptote. My domain is going to be the set of all real numbers x, such that x cannot equal 0. My range will be the set of all real numbers y, such that y cannot equal 0. And my asymptotes will be x equals 0, y equals 0. And I'm going to go ahead and take my highlighter and highlight my asymptotes. So x equals 0 and y equals 0, the same as what we highlighted earlier for our parent function. All right, now notice that the pink is farther away from the axis. So I need to make sure I mention that. So G is farther from axis than F. All right, and that's everything.